to our YouTube channel, Zyxel America's channel, Zyxel Channel America, something like that. I've also done this presentation or a similar version of this presentation in the past, so those recordings are up there as well for you. As we go through today, please go ahead and send in questions using the question and answer interface in Zoom. And I will try to answer those as we go through today. For something that I can't answer right away, I'll save it till the end. But feel free to send those questions in as you come across them. So today we are talking about Wi-Fi 6, aka 802.11ax, aka high efficiency wireless. So all the different names that Wi-Fi 6 has or has had over the past there. It's a big change to what's going on with Wi-Fi. So the original Wi-Fi spec was defined all the way back in 1997. In 1999, OFDM was introduced, and that really has been the primary, last really heavy-duty change to the Wi-Fi spec. Most of the stuff since then has been just increasing the encoding QAM a little bit and has been increasing the bandwidth available to use for a single device. So it started off using approximately 20 megahertz channels, jumped to 40 with 11N, and jumped to up to, I think, 160 megahertz channels with 11AC Wave 2. Really important thing to note here is when it comes to whoops, that's not the tool I want. I don't want the pen. I want the pointer. There we go. When we come to 11AC, which is what we've been using, pretty much since 2013, it's only on the 5 gigahertz radio. The 2.4 gigahertz radio is still using 2009's 802.11n. So 11AX is actually changes to both radios, the 2.4 and the 5. So a big jump up for both of them. Officially, it's not completely ratified yet, but it finally just passed the last major hurdle. So there's one last vote that needs to take place, which was scheduled for Q1. I'm not sure if that's going to get pushed back due to COVID or not, but it's basically on the door as far as being a final standard, even though product's been shipping and calling itself Wi-Fi 6 for at least 3 years now. So before Wi-Fi 6, Wi-Fi was what we call contention-based. Basically, one device can talk at a time. If two or more devices talk at the same time, you get interference, you get a collision, and you get drop packets. There was no coordination of whose turn it was to talk. There were no real tools in there to help identify who you're trying to talk to. So Wi-Fi 6 tries to solve these issues and more by making better use of airtime, by taking use of scheduling and a bunch of other technologies that really go to solve a number of Wi-Fi's problems that have been haunting Wi-Fi for a long, long time. So we'll go through some of these technology changes here for us. So theoretically, Wi-Fi 6 can get up to 9.6 gigabits per second. We're not shipping anything that's anywhere near that fast at this point, but that is the standard spec. The nice thing also with Wi-Fi 6 is it's designed to be used on multiple different radios. So it can be used on your 2.4 gigahertz radio, it can be used on your 5 gigahertz radio. And coming out here soon will be Wi-Fi 6 Enhanced, which uses the 6 gigahertz spectrum to be able to operate. So all of those are using the Wi-Fi 6 standard. So it's designed to handle more users in the same space and to handle more access points in the same space. So it's really good for situations like apartment buildings and condos where you've got a lot of neighbors all with their own networks, shared office buildings where you've got a lot of small offices. It's also really good in places like convention centers, meeting rooms, conference rooms, things like that, where you've got a large number of users in a space that you need to cover. So Wi-Fi 6 allows us to do 8x8, so transmit and receive 8 different spatial streams. It also now has the ability to do multi-user MIMO, both upstream and downstream. So 11AC itself could not do multi-user MIMO. 11AC Wave 2 introduced the ability to do multi-user MIMO from the access point to a client device, and Wi-Fi 6 now allows multiple client devices to transmit to the access point at the same time. We've upgraded from OFDM to OFDMA, which gives us a lot better use of the spatial areas there. Resource unit scheduling, higher encoding with 1024 QAM, technology called BSS color coding, and TWT, target wake up time. So TWT, because I don't have a slide on it, TWT basically helps solve one of the issues we run into with smart homes, right? With a smart home, you've got these little Wi-Fi plugs all over the place, but they don't need to necessarily check in that often. So TWT basically tells them they can sleep and tells them when it's going to be their turn to talk, so they can save power and save airtime while waiting for their turn. So OFDMA is a big change here for us. Basically, all 802.11 AC Wave 2, when doing multi-users, would basically break up the channels into 20 megahertz sections. So if you're using 40 megahertz 11 AC Wave 2, you could have two different users using it at the same time, each with a 20 megahertz channel. With OFDMA and Wi-Fi 6, we're now able to dynamically assign channels in much smaller resource units. So you're now able to take these channels and divide them up instead of dividing up your 40 or 80 megahertz channel into 20 megahertz sections. You can divide them up into sections as small as 2 megahertz. So it allows you to much more dynamically assign and use your airtime based on how much bandwidth is actually needed for each client device. Something streaming video can get allocated a big chunk of the available airtime there, while something small, again, like a smart home device, can just be designated, a very small chunk of the airtime bandwidth there. So it's not eating up that space. Where with the old version, even if you only needed, 2 or 4 megahertz of bandwidth, you were getting a minimum of 20. So there's also a new technology called BSS coloring. So this is designed to help deal with co-channel interference, right? So again, traditionally with Wi-Fi, devices take turns broadcasting. So if you end up in situations where you've got access points operating on the same channel near each other, they can cause interference, especially a big problem with 2.4 gigahertz, where there's only 60 megahertz of bandwidth available. So with BSS color coding, the packets are actually basically branded with the BSS that they're trying to communicate in, allowing an access point basically to take a quick look at the packet as it comes in, see if it's intended for itself or not. And if it's not, it can ignore it and reuse that space. So it takes into account things not only just that, but signal strength and stuff like that to determine what is noise from another device operating on the same frequency and what is data intended for those devices. So it really helps with cramming more APs into the same area before you start encountering significant interference. So 11AX also, using these technologies helps us optimize the available band time, airtime utilization. So we've got this yellow stripe up here. This is Wi-Fi 6 device. And then we've got this orange stripe here. This is a typical 11AC device. And down here, as we go across this axis, it's showing us how many users are there and the aggregated throughput. So you can see with Wi-Fi 6, as you add more and more users onto the access point, the aggregated throughput stays pretty much level. Where with 11AC, as you start adding more devices, the aggregated throughput drops as you add more devices, just due to how inefficiently Wi-Fi historically has used the airtime. There's no coordination of which client's term it is to talk. There's no being able to tell devices to pause and wait for a little bit, none of that stuff. So Wi-Fi 6 better utilizes the airtime to maximize throughput. So same thing now with two APs in the same area. So the aggregated throughput's jumped up here to about 1300 megabits. Same thing as you start adding users with Wi-Fi 5 or 11AC here. As you add users, aggregated throughput goes down. Wi-Fi 6 aggregated throughput stays pretty solid. So as I was mentioning earlier, the Wi-Fi 6 standard isn't officially 100% ratified yet, although it's basically there. However, people have been selling Wi-Fi 6 products for about 3 years now. So how is that? And it was similar to, for those of you that are old like me that remember 11N, you might remember there was a lot of pre-N product that came out before the 11N standard was ratified. And those pre-N products, for the most part, could not be upgraded to the full 11N. And it's the same thing here with Wi-Fi 6. A lot of these early products and even some new products that have come out that are using the older chips to save on price are missing some of the key features that makes Wi-Fi 6 such an improvement over 11AC and previous Wi-Fi technologies. So those first chips were using what we call a Gen 1 chip. Here on the screen, I've got Qualcomm's breakdown of what the differences are between Gen 1 and Gen 2. Broadcom is also in a similar boat, but you can see here the ability for multiple user upstream to the access point isn't supported on those Gen 1 chips, and it cannot be upgraded to it. Um, Upstream OFDMA, same story. TWT, not there. BSS coloring, not supported. So these chips that support the full Wi-Fi 6 feature set weren't actually available until late summer, early fall 2019. So anything that came out before that is definitely using a Gen 1 chip and is missing some of those key features. And unlike the good old days of pre-N, these simply are where the labeled these products as pre-N. A lot of these companies selling using these old chips labeled their devices as just standard Wi-Fi 6, and there's no way to really know that they're not supporting the full Wi-Fi 6 feature set without just looking at their data sheet and trying to see if any of these features are missing that should be there. So it's something to keep in mind. Another thing that's just recently happened, Ubiquiti has launched their line of Wi-Fi 6 access points, but they're only using Wi-Fi 6 on the 5 gigahertz radio. The 2.4 radio is still using 2009 11N technology in order to save price. That's something else to keep in mind. Wi-Fi 6, is the first major enhancement to the 2.4 radio in over a decade. And yet Ubiquiti and probably in the future some other lower end vendors aren't going to be giving you that upgrade on the 2.4 radio. And again, they don't advertise Wi-Fi 6, but only on one radio. They call it a Wi-Fi 6 AP. And you've got to look at that data sheet and realize that the speeds don't match what you would expect to see on a 2.4 radio using Wi-Fi 6. So just some things to keep in mind. All Zyxel Wi-Fi 6 products are using Gen 2 chips with full support for all the Wi-Fi 6 features. So this is our current portfolio of Wi-Fi 6 APs. You can see we've currently got 5 models available for you. Let's see what's going on here. So I'll go ahead and let James send in a question. He's asking, is Wi-Fi 6E on our roadmap? So it is on the roadmap. It is something we are actively working on. I cannot tell you when Wi-Fi 6E product will be here. Probably end of the year at the earliest, just as we wait for the chips themselves to mature a little bit. Just as with Wi-Fi 6, those first gen chips were missing some features. It's fully expected that there will be some missing features or some performance issues with the first gen chip. So we're going to wait for the 1.2 or 1.3 or whatever version of the chip to come out before we jump into it. And at the same time, in order to use Wi-Fi 6E, client devices also have to support it. And there really isn't anything out there in any significant quantities that supports Wi-Fi 6E. And those products will be a bit on the expensive side since they're going to have 3 sets of radios, 3 sets of antennas, one for 2.4, one for 5 gigahertz, and one for 6. Back to the slide. So here's our portfolio. We'll start by talking about our first 3 Wi-Fi 6 APs that we launched. The NWA 110AX, which is our entry-level model, the WAX 510D, which is our nice mid-tier model here, and the WAX 650S, which is our high-end model. So NWA 110AX here. So again, Wi-Fi 6 on both the 2.4 and 5 gigahertz radio, supporting 2 spatial streams in both directions on each radio. This is a Nebula Flex AP, so it can be used standalone where you manage it directly, or you can manage it through our free cloud service, Nebula. It does have the filter built in there for 4G and 5G filtering to keep interference from those. And even though this is our entry-level AP, it follows Zyxel's design philosophy of over-engineering our access points. For those of you that are new to Zyxel, if you haven't gotten it yet, grab one of our APs, even our cheap $89 one. Grab any of our competitors, whether it's Ubiquiti, whether it's Ruckus, whatever, and you will feel our access points weigh a lot more than our competition. So there's some things that we're doing a little bit differently. So to begin with longevity, on these solid state devices, there's 2 main causes of failure. The first one is capacitor failure. So electrolytic capacitors have a tendency to leak, boil over, dry out, whatever. So we only use solid state capacitors on our board. The other major cause of failure over time is heat fatigue. Basically, these chips run hot, and over time, that heat can cause the little switches inside to fail. It can cause solder joints to fatigue and separate. So on our access point, we've got, you can just barely see it here, we've got a large metal heat sink that goes behind the PCBA on all of our access points. And then we've got a large number of vent holes in the top of our access point. So this pulls heat off of the board and vents it out the top, helping prevent heat fatigue. If you check most of our competitors, most will not have any sort of heat sink behind the board to remove heat. And certain vendors like Ubiquiti won't even have vent holes to let the heat out. So basically those access points are just sitting in there cooking in their own heat over time. One of the reasons why we can offer a lifetime warranty even on our entry level access points where certain other brands are only offering a 1 year or 2 year warranty out of the box on their entry level APs. The next thing you will see if you open up our boxes, and if you've been to a trade show, we often have a Ruckus and a Ubiquiti AP opened up as well as one of ours, so you can see this yourself. We have a lot more EMI shielding on the board. So it doesn't help with longevity, but it gives us a little bit of a boost of performance. It costs a little bit extra money, putting extra shielding on there instead of just doing the minimum. But it helps a little bit with receive sensitivity. The other difference is we do not mount our antennas directly onto the PCBA like most of our competitors. Instead, we have a separate metal board that acts as a heat, or not as heat shield, acts as an RF shield to help create isolation between the antennas and the PCBA. Again, just to give us that much little boost in receive sensitivity. So the combination of the extra shielding and moving the antennas off of the board can give us up to a 3 dBi gain in the receive sensitivity. Um, so it's a doubling of your receive sensitivity essentially. So it doesn't make a lot of difference if you've got a nice strong signal, but if you're an edge case on the edge of the coverage area, it makes a big difference as far as how far you can get away from the AP and have a reliable connection. So what is Nebula Flex for those of you that haven't had this drilled into your head yet by our presentations? So Nebula is our cloud management network platform. It allows you to manage an unlimited number of devices, an unlimited number of customers for free through the cloud. Helps simplify things. It's a really nice tool. So Nebula Flex allows you to use a device as a standalone device, managing it directly through the web GUI, managing it through a CLI, managing it through SNMP, or managing it through the cloud. And it's a true cloud platform. There's no cloud keys, there's no wireless LAN controllers, there's nothing that needs to go onto your network. The agent to connect to the cloud is built into the access points themselves and our switches and our gateways. So you can use that, and it's really easy to switch between modes. So you can always do, standardize in one product and use, for some customers, use it cloud managed, for some customers, direct managed. So let's talk a little bit here. WAX 510D, basically very similar hardware to the NWA 110AX, 2x2 spatial streams. The upgrades this gives you over the NWA 110AX is it gives you what we call dual optimized antennas. So instead of having one set of antennas built into the AP optimized for ceiling mount, like on most APs out there, this has two sets of antennas, one optimized for ceiling mount, one optimized for mounting on a wall. And you can switch between those antennas based on where you've mounted the device. So if you're in one of those situations where you just can't mount it up on the ceiling for whatever reason, you're not wasting a lot of your antenna pattern by sending signal up into the floor and ceiling like you would trying to mount a typical ceiling mount AP onto a wall. You can simply flip the switch and turn it into a wall mount AP with optimized antenna coverage. In addition, this also supports Nebula Flex Pro, and I think I've got a slide on that. Oh, maybe I took it out. Okay, so Nebula Flex Pro, same story as Nebula Flex, with two differences. In addition to standalone or free cloud managed mode, you can also manage these APs with one of our controllers, either our dedicated NXC wireless LAN controller, or just about all of our Zywall USG ATP security gateways can be used as a wireless LAN controller. So you can have a one box solution. So Nebula Flex Pro gives you those three options. It also includes a 1 year subscription to Nebula Pro, which is an optional add-on to Nebula, which unlocks some additional features for you. And again, same story, same design philosophy here, solid state capacitors, giant heat sink on the back, antenna isolation, etc. So here's a little graph here showing you most APs are designed to be mounted on a ceiling centrally in a location. But in the real world, we can't really do that. So sometimes you have to mount these APs on the wall. And when you do that, generally, you're rotating the antenna, the coverage pattern 90 degrees from what it's designed for. So you end up getting poor coverage. So the dual optimized antenna, you can switch to a dedicated wall mount um, design. Oh, and here's my Nebula Flex Pro slide. I guess I did have a slide for it. Sorry about that. So anyway, just lets you decide whether to do controller managed, standalone, or Nebula cloud managed. So this is just showing us here, showing the WAX 510D against some of our competitors, in this case, an Aruba 505, and the Ingenious EWS 357 AP or the ECW 220, which are the same hardware, different software loads on them. So you can see here the Ingenious is pre-11AX. It is not true Wi-Fi 6. It's missing a number of features that both Zyxel and Aruba offer. Only the Zyxel is offering dual optimized antennas. We also have higher power output on both the 2.4 and the 5 gigahertz radios for a little bit better coverage there for you. All of these are using a 1 gig Ethernet backhaul. All of them are using standard 802.3 AT power, except the Ingenious, which is using 802.3 AF. So this is just showing here speeds. The orange and yellow are throughput as tested when in the different antenna modes, ceiling versus wall mount. And then the blue is the performance that you are seeing from the Aruba. So you can see here we outperform them or match them in performance. You'll notice that when we're doing ceiling mount antenna pattern versus their ceiling mount antenna pattern, at the farther ends, they sort of match up there. This is just showing a similar story on the 2.4. And then this is our flagship model, the WAX 650S. So this is bumping up from basically doubling the throughput that you can get on the wireless with 4 spatial streams on both radios. This adds our smart antenna technology to it. It upgrades the uplink port from a 1 gig on the other models that we've been talking about, gives you a 5 gig Ethernet copper uplink, and this supports Nebula Flex Pro. Not too big of a box considering all that we've crammed in there for you. So same story as far as the construction goes. Some other things to draw your attention to on this is this access point has a dedicated third radio used for channel monitoring and scanning. So you can use this to keep an eye both on DFS channels, so you know which other DFS channels are available if you need to switch channels. Also helps you with things like security scanning for rogue access points. And it also has Bluetooth low energy built in. So this can be paired up in retail environments, warehouse environments to use Bluetooth low energy for various smart operations. So here we go. If you're not familiar with smart antenna, we've got a couple slides talking about this. If you're used to Ruckus, it's similar to their smart antenna technology that they have in their devices there. Basically, smart antenna technology helps solve co-channel interference issues, allowing you to increase the number of devices that are connected to the access point, reducing interference between devices, increasing the overall coverage, and being able to optimize power utilization. So your traditional AP, as I've mentioned several times, is designed to be mounted in a ceiling directly over the area that's supposed to be covered. So it's got this sort of round antenna coverage pattern. If we looked at it from the side, it would look kind of like an umbrella. Some devices have built-in directional antennas. You see this a lot with outdoor point-to-point APs, where they've got just a focused dedicated beam. So this is showing you, here's your typical AP mounted up on the ceiling. It's got that nice round antenna coverage pattern. You throw in some other device that's using the same spectrum. In this case, it's a microwave, but it can be other access points, wireless cameras, anything that's using 2.4 or 5 gigahertz spectrum to work. Basically, that device puts out sound on the same frequency and can cause interference with your client's degrading performance. This is one of the big, banes of trying to do coverage in like a convention center space where you've got a lot of open space and a lot of users, and those access points are basically interfering with each other and covering each other up. So, smart antenna, same situation. It has the ability to go through literally hundreds and hundreds of different antenna patterns and choose the appropriate antenna pattern based on where the client device is in relation to the access point. But also, our algorithm takes into account other sources of RF interference and basically tries to ignore and not listen to those other interfering co-interference on the same channel. So that helps you out a lot as far as being able to increase coverage here. So here we've got a comparison between our WAX 650S, Cisco, both the standalone Cisco Meraki, Aruba 535, and the Ruckus R750. So all of these are dual band. Only us and Ruckus have any sort of smart antenna technology in there. If you look here, we have higher output power than basically everybody on the 2.4 radio, and higher output power than everybody but Ruckus, where we match Ruckus on the 5 gigahertz radio output power. All of these are 4x4 access points with 4 spatial streams. Only the Zyxel has the dedicated third radio for monitoring. Excuse me, only us and Meraki have that. Ruckus and Aruba do not. And you see here, only us and Aruba have the 5 gigahertz backhaul connection. The Cisco, the Meraki, and the Ruckus only have a 2.5 gig backhaul connection. We do have a dedicated 1 gig port going out, so you can daisy chain stuff here. So again, this is comparing us with smart antenna against Aruba, who does not have smart antenna. And you can see pretty significant differences in the coverage here of the sort of throughput you could expect to see. This is the 2.4 gigahertz radio. Same story on the 5 gigahertz radio. So one thing to talk about on the WAX 650S, it requires more than 30 watts of power to be able to operate at full speed, because we're powering 2 really fast radios and then 2 other radios, right? A monitoring radio and a Bluetooth radio. So because of that, to get the full speed, you need to pair it with a PoE device that provides 802.3 BT power, which can provide up to 60 watts of power per port. So that would be our XGS 1930-12HP. It provides that 802.3 BT technology and supports the multi-gig Ethernet ports up to 10 gigs per port there. So this is what you generally want to pair this with. Having said that, if you for some reason can't, we do sell an AC adapter you can use to get you full power, or you can just use it on any standard 802.3 AT PoE switch, and it will just throttle down its speeds so it doesn't exceed the power requirements of that switch. So if you don't want to upgrade your switches, it will work. It just won't work at full speed. So we'll move on to our two newest. Whoops, getting ahead of myself here. So just a quick summary here. Both the NWA 110AX and 510D are both giving you the same Wi-Fi performance. They've got both have the same uplink, but going from the NWA 110 to the WAC 510D gets you the dual optimized antennas and gets you Nebula Flex Pro versus standard Nebula Flex. And then going up there from the WAX 510D to the WAX 650S, you're getting the Bluetooth radio, you're getting the dedicated scanning radio, you're getting smart antenna technology, you're doubling the wireless speeds, and you're getting a 5 gig backhaul. So now we've got 2 newer models here, the NWA 210AX and the WAX 610D. So we'll touch on these briefly. Both of these over the 110 and the 510 gets you faster 5 gigahertz radio, double the speed on the 5 gigahertz radio. And it also give you a 2.5 gig Ethernet uplink instead of the 1 gig port. So the NWA 210AX supports Nebula Flex, just like the 110. And this is basically going to be your step up from the 110. If the 110 doesn't have the performance you want, this would be the step up and get you the same sort of feature set, just with faster 5 gigahertz radio, faster uplink. 610D gets you the dual optimized antenna, gets you Nebula Flex Pro over Nebula Flex. And again, same sort of technology behind them as far as longevity, the heat shield, the extra shielding on the board, removing the antennas from the PCBA and mounting them up above it. So that gives you our full lineup of current lineup of Wi-Fi 6 access points. So we've got a huge range here. These guys start at under $200, going up to around $650 for this guy here, and a bunch of stuff in between. So you should be able to find something that fits your needs. The Wi-Fi 6 access points have introduced a new type of mounting bracket that's a lot more flexible than the old mounting brackets. So this new mounting bracket is designed to fit a round junction box with screw holes in it, a typical rectangular junction box to be mounted directly onto a wall or ceiling with screws, and it can be paired with our drop ceiling T-bar mounts to be able to clip on to a drop ceiling without having to punch any holes into the drop ceiling. It just clips on the T-bar that holds the acoustic panels up there. And that, guys, ends today's presentation. Feel free to send in questions here. And I see there's a number there from Anthony, so I'll get to his in just a second here. I do want to draw your attention here. You know what? I missed a PowerPoint slide. I must have it set to hidden. So I thought I had a slide in here. Recently, a third party has done a comparison between our Wi-Fi 6 AP, our entry-level one, that NWA 110AX, and Ubiquiti's Wi-Fi 6 AP. So if you go to YouTube and just type in Zyxel Wi-Fi 6 or Zyxel Ubiquiti Wi-Fi 6, you will see the YouTuber who did it. Shoot, I don't know why that slide's not in there. I forget the name of his channel off the top of my head. But it comes right up if you put in like Zyxel Ubiquiti Wi-Fi 6 in YouTube. So you can get somebody, he did some tests comparing the throughput on both radios, 2.4 and 5. It's a really nice review that the guy did. So you can check it out. If you don't want to believe me about how good our Wi-Fi 6 stuff is, you can check him out and see what he had to say. There's also another YouTube reviewer in Russia who's done a comparison. Hopefully we'll see some more coming out here. The Ubiquiti Wi-Fi 6 APs have been really limited availability. So they're just now starting to become more widely available. So hopefully we'll see some more comparisons between us and them, and maybe us and Ruckus and stuff in the near future. And we do have a user forum, forum.zyxel.com. Please check it out. It's a way to talk to your other Zyxel users and installers. And it is a forum that is monitored by our R&D and tech support teams. So it's a way to provide feedback direct to the guys who can make those changes. Okay, on to the questions that we've gotten. I see Doug has raised his hand, but Doug, I need you to type in any questions you have using the Q&A box. So Anthony is asking about pricing tiers for K through 12. We do have a GovEd discount. Just reach out to your salesperson, Jacob or David. They can talk to you about what that discount is. I don't know it off the top of my head, but I do know we do have a dedicated GovEd program. NFR units are available for testing. Again, your salesperson, Jacob or David, they can help set that up for you. Peter's asking availability on models. All 5 models are available and should be available through distribution. Target, I think, has the biggest stockpile of Wi-Fi 6 APs, but any of our distribution partners should be able to get their hands on them. Just in general this year, stock is going to be intermittent off and on. Unfortunately, due to the chipset vendors. Generally on these types of devices, lead times on the components are generally around 12 weeks. Some of the harder to get products, the components lead times generally around 16 weeks. Qualcomm has recently come to us and told us they need more than 40 weeks lead time. Broadcom, depending on the chip, has told us up to 54 weeks. Yes, a whole year lead time now on something that used to be 16 weeks. Basically, it's due to COVID. When COVID hit, not only did some of the fabs that make the silicon shut down, but when they came back online, they moved production over from what they had been making and focus more on cell phones and other consumer electronic stuff used in the home. So because of this, unfortunately, there is a shortage of the silicon that's available. So it is causing us to have some intermittent stockouts in some of these Wi-Fi 6 APs because of the sudden change in lead times. And it's not something that's just affecting us. It's affecting everybody in the industry right now and other industries. You may have seen in the news that just about every major automaker has either scaled back production or had to idle some of their plants because they can't get the computer chips that go in the cars. Obviously, it's not the same chips going in the cars as our access points, but it's the same situation where, unfortunately, there's a shortage of the raw components and lead times have just skyrocketed in the last 3 months or so. But yes, all those models should be available, and if they're not in stock, we can get those. Go ahead and get a back order in place, so they'll ship to you as soon as they are available. But I think right now all of the models are available. I don't think we're currently stocked out, but it is something that we may be facing going forward. So Anthony was asking how we compare to Ruckus. So Ruckus is our main competitor, probably in the higher end products, the 500 and 600 series products. We've been competing with them for years. Um, there was an independent third party in Italy, the University of Brescia, their networking group, and it's a few years old now, but they went out and they tested our smart antenna versus Ruckus's smart antenna versus Cisco's non-smart antenna and Aruba's non-smart antenna. And not only were we outperforming in real world tests, the Cisco and Aruba products that don't have smart antenna, our smart antenna implementation was significantly faster in real world scenarios than the Ruckus was. Our pricing should be much more competitive than Ruckus is. And obviously, we've got the free cloud solution where Ruckus doesn't offer a free version of their cloud. It has a bunch of different licensing things that we don't have on our products. But yeah, we should always be a very close match as far as products go, performance wise, and then we should be able to beat them on price. And then Anthony's asking here, what distributors are we able to purchase these through? So it's all of our main distributors. So we go through Wave Wireless, Target Distribution, Ingram Micro, and DNH. So if you're selling our products, you should be part of our partner program. So as long as you qualify for the partner program, it's something we do for value-added resellers, and it gets you some significant discounts through distribution, specifically to help you be able to match Amazon-type pricing and still have some margin for yourself. So you do have to apply for that. It's available on our website. Just go to us.zyxel.com. Go to click the partner tab, and there's an application you can fill out to join. And that's where you'll be able to get those automatic discounts that are applied through distribution. It'll allow you to do deal reg for even greater discounts. It'll get you access to the GovEd program. It'll get you access to NFRs and stuff like that. So definitely, if you are a value-added reseller, not just somebody who sells online, join the program, get your discounts, get some money. And then Anthony's also asking about support. So yeah, if you're buying through the US, all support is done through Zyxel here in the US. So when you call in, you are dealing with Zyxel employees located here in California. Our headquarters is based out of Anaheim, California. So we've got better West Coast hours than we do East Coast hours. But you'll call in and you will talk to somebody that's located here that works at Zyxel. I think for a while, we were using a third party later in the evenings to try to expand hours, but we stopped doing that. And I know we've also been working at using our German tech support team. I think in some of the early morning hours is sort of an overflow. I'm not sure if we're still doing that or not. I know that was something we were experiencing with, but still same thing. You'd be dealing with Zyxel employee, although they might have a German accent. And then they would pass it off and hand it off to the US team when the US team comes online. So hope that answers that question. I've got no more questions in the queue. So I'm going to go ahead and end today's webinar. If you do have something, my email is right up there on the screen. Sean spelled SHAWNR at Zyxel.com. Feel free to reach out to me directly or, loop in Jacob and Try or David, and they can help get those 8 questions answered. We do also have a sales engineer that you can use if you're part of our partner program. So again, if you are a member of the partner program, reach out to Jacob or David, to see about using Marcus to help you out with planning, to help you spec out stuff for your customers, to answer some pre-sales questions. Marcus is really great at that. So that's another tool and resource available for you. But thanks for joining, guys. I really appreciate it. Thank you.